All right, so we are going to continue our work with solving inequalities by addition and subtraction, and we're going to look at a problem that I thought was pretty interesting. I'm going to call it a challenge and a real-world connection problem. And it connects to geometry also, and here you go. A triangle inequality theorem says that the two smallest sides of a triangle must combine to have a total length larger than the largest side of the triangle. Write an inequality that states what the possible lengths of the missing side could be for a triangle with sides of 6 and 11. And I want to show an example of why this theorem actually makes sense. So not using the given dimensions yet, but let's say we had 3 sticks, and one stick was 100 centimeters long, and one stick was 5 centimeters long, and one stick was 8 centimeters long. So here's an example of 3 possible sides of a triangle, so 3 sticks, right? And we're trying to see if could we arrange these 3 sticks into an actual triangle. Okay, the triangle inequality theorem says that we can't, because the 2 smallest sides, 5 and 8, have to add up to be larger than the largest side. And the way I like to think about this is, what if we brought this guy over here and this guy over here, and we then actually tried to make a triangle? They don't meet, right? They can't touch. They're not long enough. The 5 and the 8 aren't long enough to touch. So we have this giant gap here that we have to deal with. We simply have 100 centimeters that is too long, and the 8 and 5 are too small. Okay, so let's actually look at this particular problem here. And the way that I like to do it is to arrange the sides in order from smallest to largest, sort of as a spectrum. Okay, and so we have sides of 6 and 11. So obviously 6 is larger than 11, or 6 is smaller than 11, sorry. But we don't know if 11 is the largest side or 11 could be the middle side, but we know that 6 can't be the largest side. So we have a missing side here, okay? And that missing side could be the smallest side. That missing side could also go in here or in here. We don't know where. The missing side could be the middle side, or it could be the largest side. So I'm going to write them in order using our 3 different possibilities. We have a second possibility looking like that, and then the final possibility looking like that. So as we just order the possibilities from small to large, could be x 6 11, 6x 11, etc. Okay. So what this is telling us is that, or what the triangle inequality theorem says, is that the sum of the 2 smallest sides have to be larger than, it can't be equal to, it has to be larger than the largest side. So we can write some inequalities here. Okay, so we just applied the triangle inequality theorem to each of our 3 possibilities. I think you can see that the first 2 inequalities are identical, so we don't need to write them both. And we can subtract 6 from both sides in the first one and get that x has to be larger than 5. So that's a portion of our solution right there. And we can simplify the final one and say that 17 has to be larger than x, which really means x has to be less than 17. Okay, so what that says is x has to be larger than 5, and also additionally x has to be smaller than 17. And we can write that as a compound inequality, like so. And that would be our final answer right there. If you have side lengths that fall outside of the range of 5 to 17, even if they're 5 or 17 exactly, you would not be able to make a triangle. All right, that's a good place to stop right there.